6-3 Part 2. Let's finish up solving systems by elimination. First, let's get the definition written down, because you never know when you may need that. The elimination method is simply solving a system of equations by adding or subtracting, but you knew that already. Now, let's take a look at this system right here. Negative 2x plus 15y equals negative 32. 7x minus 5y equals 17. Doesn't matter whether we add or subtract. We're not going to eliminate anything right away like this, are we? But do you notice these y coefficients? 5 is a factor of 15. So can we multiply that entire equation, both sides, by 3? I think we can. So that whole equation becomes 21x minus 15y minus 51. Don't forget to multiply both sides. So now we have, notice this first equation stayed the same. The second equation multiplied by 3. Now we have matching coefficients. And it's already one positive and one negative, so we can just add them together. We end up with 19x equals 19, x equals 1. Lovely. Substitute 1 back into either equation. Y equals negative 2. And our answer, the ordered pair, 1, negative 2. Not too terrible. Try got it number 3. Only do letter A. Don't worry about letter B. So here's our system for 3A. And unfortunately, none of our variables are going to just vanish by simple adding or subtracting. But notice that 2 is a factor of 6. So if we multiply the entire equation by 3, as long as you do the same thing to both sides, it's all okay. Negative 15x minus 6y equals 12. So come back and line those two equations up so you may add them. Negative 12x equals 18. X equals 1.5. And as you can see, I'm about as happy at working with that as you are. It's fine if you decide to work with negative 1.5 as well. So substitute that negative 1.5 back in. Your math should look something like this. And your final answer will be either fractions or decimals. So, you know how to solve a system by adding equations. You know how to solve a system by subtracting equations. You know how to solve a system by multiplying one equation to get them to line up so you can add or subtract. What's left? That's right. Solving a system by multiplying both equations. I'm on page 376 in your book. We're going to go through this quickly because by this point I think you've got this figured out. Here's your system. 3x plus 2y equals 1. 4x plus 3y equals negative 2. And all of a sudden this feels to me a lot like trying to find common denominators so you can add or subtract. Take your pick. I'm going to choose to multiply by 3 and 2 because those numbers are smaller than multiplying by 3 and 4, which is another option. And there we go. And multiply the top equation by 3. Multiply the bottom equation by 2 so that you end up with 6y's. Then you have to remember to subtract and distribute that minus sign. You end up with x equals 7. Put that back in, right there. Y equals negative 10, and you're not done until you get the ordered pair. Give it a try with got it number 4, top of page 377. So, got it number 4. Here's the system that we're given. And yes, we're going to have to multiply both the top and the bottom. I chose to multiply the top by 2 and the bottom by 3. Notice I'm using positive 2, positive 3 in both cases. We'll figure out after the multiplication step whether we need to add or subtract. And once you multiply each of those, you end up with this. 8x plus 6y equals negative 38. 9x minus 6y equals negative 30. Fortunately, we've got one positive, one negative. We can just add them. 17x equals 68. Cross your fingers that 17 goes into 68. X equals negative 4. Substitute the negative 4. Y equals negative 1. Your solution, negative 4, negative 1. Now, each of these sections, 6.1, 6.2, and now 6.3, has ended with examples where there are no solutions or where there are infinitely many solutions. And I've kind of been skipping over it because it doesn't involve a whole lot of actual math. You are going to have a couple of practice problems in tomorrow's classwork, so I'm going to go over this quickly one more time. Here's your system over here. 2x plus 6y equals 18, and x plus 3y equals 9. Can't do much with it like that. Multiply the second equation by 2. Oh, they just go ahead and multiply by negative 2. Look at that. So you do that, and you solve it, although I'm kind of sad that they felt you needed to solve it. Once you get to this point, right here, you should realize that there are infinitely many solutions because any number that you plug in for x and y is going to work. Infinitely many solutions, which means what? If we were to graph that, what would the graph look like? Think about it. The other option is if you were to solve this and nothing works, that means that your system has no solution, which means something else. So think about that too. Down here, one very helpful thing. If you are still, as someone I know says, combafflated, if you are still combafflated by the process in this chapter, this flowchart on page 377 might be just the ticket. Look at your system. Can you eliminate a variable by adding or subtracting what's given? If you can, do so. If you can't, then can you multiply one of the equations by a number and then add or subtract? If you can, do so. If you can't, multiply both equations by different numbers, then add or subtract. The other flowchart that I think would be helpful at this point is this chart. Which process to use? You've got 3 of them now: graphing, substitution, elimination. You haven't yet started to figure out when to use which one, so I made you this handy chart. Start over here. Is the system graphed? If it is, use graphing. If it isn't, go on. Is one equation already solved for x or y? In other words, x equals some kind of y plus something. or y equals some kind of x plus something. If it is, use substitution. If it's not, use elimination. You might have a problem concerning this on your classwork. Speaking of which, here it is. I didn't put a page number on there. Let's fix that. Page 378 and 379, 16 to 36 even, number 42, if you have time. Enjoy!